Good day everybody. We have a Putnam Exam integral. Integral 0 to 1 ln of x positive 1 over x squared positive 1 times dx. Now we will be using a special property from integral. Now if we do not use that property, then to handle this integral is a bit complicated. It will become too much tedious, involving many steps. Okay, so having mentioned that, let me state this property. We know that integral a to b f of x times dx is equal to integral a to b f of a positive b negative x times dx. This is called as the King's property in integrals. And the speciality of this property is the x that you see here is replaced with a positive b negative x. So having given you this property, I will be utilizing this property. So before I could utilize this property, I would like to perform some changes in the integral. So for that, let me just let x be equal to tan theta. So what am I doing? I am preparing the integral so that I would be in a better position to apply the King's property. That is my intention. So for that, let's start with taking x be equal to tan theta. I differentiate both sides. When I do that, on the left I get dx, on the right differentiation of tan theta is secant squared theta times d theta. Okay, fine. So therefore, integral 0 to 1 ln of x positive 1 divided by x squared positive 1 times dx is rewritten as, I'm not going to do anything with the limits. Let me come back to the limits. Now let me make the substitution. In place of x, I have tan theta followed by positive 1 divided by x squared, that's going to be tan squared theta positive 1, and my dx is going to be secant squared theta d theta. Now let us handle the limits. Now when x is equal to 0, what value of theta will give me 0? Let me write that. When x is equal to 0, clearly theta should take the value 0. And subsequently, when x is equal to 1, theta will take pi divided by 4. Why? Because tan 45 is equal to 1. So having set up the limits, let me place those limits 0 to pi over 4. Now there is a trigonometric formula. What is that? Let me write that formula there. Secant squared theta negative tan squared theta is equal to 1. So from here I get secant squared theta is equal to 1 positive tan squared theta. So in place of tan squared theta positive 1, I am going to use secant squared theta. So let me do that. So this is equal to integral 0 to pi over 4 ln of tan theta followed by 1. This is secant squared theta. Over here I get secant squared theta d theta. Now secant squared theta gets cancelled, giving me 0 to pi over 4 ln of tan theta positive 1 d theta. So over here this is nothing but my f of x. So what I wish to do, I would like to replace theta by 0 positive pi over 4 negative theta, which is nothing but pi over 4 negative theta. So let me do that. So this is equal to, by King's property, integral 0 to pi over 4, the limits will not get changed, ln of tan of pi over 4 negative theta followed by 1 times d theta. Now what is this? Now we know a formula. What is that? Tan of a negative b is equal to tan a negative tan b divided by 1 positive tan a tan b, right? So utilizing that formula over here, this is equal to integral 0 to pi over 4 ln of tan pi over 4 negative tan theta divided by 1 positive tan pi over 4 times tan theta, followed by positive 1 times d theta. Now what is tan 45? That's tan pi over 4 is nothing but 1. So place that value there. So this is equal to 0 to pi over 4 ln of 1 negative tan theta divided by 1 positive tan theta, positive 1 times d theta, which is equal to, take the LCM, 0 to pi over 4 ln of 1 negative tan theta, positive 1 positive tan theta divided by 1 positive tan theta times d theta. I'm just taking the LCM. Negative tan theta, positive tan theta gets cancelled, giving me integral 0 to pi over 4 ln of 2 over 1 positive tan theta times d theta. Now we know a formula, ln of a over b is equal to ln a negative ln b. Right. So I'm going to utilize this formula. Now you have to have one important observation. Now integral 0 to pi over 4 ln of tan theta positive 1 times d theta is actually on the left hand side. So make sure to place that 0 to pi over 4 ln of tan theta positive 1 times d theta. So this is 0 to pi over 4 ln of tan theta positive 1 times d theta. This is equal to this. This we got because of application of King's property. Now utilizing ln a over ln b formula, this is equal to integral 0 to pi over 4 ln of 2 negative ln of 1 positive tan theta times d theta. Now distribute the integral. This is equal to integral 0 to pi over 4 ln 2 d theta negative integral 0 to pi over 4 ln of, I'm going to write 1 positive tan theta as tan theta positive 1 times d theta. On the left, 0 to pi over 4 ln of tan theta positive 1 times d theta. Now this can be moved to the left. This negative will become positive. So you get 0 to pi over 4 ln of tan theta positive 1 times d theta positive 0 to pi over 4 ln of tan theta positive 1 times d theta is equal to 0 to pi over 4 ln 2 times d theta. Now these two can be added. So that is going to be giving us 2 times integral 0 to pi over 4 ln of tan theta positive 1 times d theta is equal to integral 0 to pi over 4 ln 2. Now I can take ln 2 out, so this is going to be d theta 0 to pi over 4. This is ln 2. Integrate d theta is going to be theta. Limits are 0 to pi over 4. So you substitute the limits, ln 2 of pi over 4 negative 0, which is nothing but ln 2 times pi over 4. So I can rewrite this as pi over 4 times ln 2. Over here I have 2 times of integral 0 to pi over 4 ln of tan theta positive 1 times d theta. But I need only this. I don't need the 2. So push the 2 down to the right side. So I will have 1 over 2 here. And this is going to be 0 to pi over 4 ln of tan theta positive 1 times d theta. Right. So this is equal to this. 1 over 2 times pi over 4 will give me pi over 8 times ln 2. So this is the solution to this integral. Now what is this integral? Let me move up. This integral that we have is actually the reduction of this integral, because since we took x is equal to tan theta, we have reduced integral 0 to 1 ln of x positive 1 over x squared positive 1 times dx to 0 to pi over 4 ln of tan theta positive 1 times d theta. So hence we have achieved pi over 8 times ln 2 to be the solution to this particular question. Thank you everybody. Enjoy your night.